Welcome to my latest video for 2025. And in this video, I'm going to go through the solutions, or at least say my suggested solution to the 2024 Specialist Maths Exam 2. I need to make an obligatory disclaimer. This slide with my suggested solution is prepared independent of VCAA, and it doesn't reflect the opinion or views of VCAA. And also VCAA reserves all rights to the exam materials. So for any further information, please refer to the assessment report to the paper. And by the way, I would like to mention a couple of things. So let me just shift to this website. And you can see this is the subject page of Specialist Maths or VCAA website. And you can see they uploaded the assessment report. And this year, VCAA actually released the marking guide used by all assessors to mark the 2024 exam 1 and exam 2. So later on, when you are moving on to your revision stages, you can use this assessment guide in conjunction with assessment report to inform your learning. And this is how it looks like. So basically, it outlines the procedures and also the policies used by VCAA, but more importantly to students. You can see the answer marks, method mark, and also special requirements for certain responses, etc. But in my video, I will focus on the solution and the possible approaches, including any potential CAS calculator approaches. So remember, for exam 2, you can always use your CAS calculator, but sometimes it may be quicker to use by hand approach, especially for some conceptual questions, or by hand approach will be much more efficient than button pressing. So you could either use your TI Inspire, your Casio ClassPad, or your Mathematica. In my video, I'm primarily using my TI Inspire as a featuring CAS calculator. So this is the instruction of section A. So you need to answer all questions in pencil on a multi-choice answer sheet. And you can actually download a PDF file of the multi-choice answer sheet and practice how you shade the answers. And now a correct answer scores 1 and incorrect answer scores 0. Marks will not be deducted for incorrect answers unless otherwise indicated. The diagrams in this book are not drawn to scale. And you need to take the acceleration due to gravity to have a magnitude g meters per squared second, where g is 9.8, not 10. So the first question is a contrapositive statement. Basically, the correct answer is C, because you need to switch the if and then part, then you negate each part. By the way, the negation of m greater than or equal to 5 or n greater than or equal to 5 is m less than 5 and n less than 5. So just be careful with the negation of this word, or, and, or. The next question is a hybrid function question, but actually this is a cancelable rational function, because if you notice, x squared plus 3x minus 10 is equal to x minus 2, x plus 5. So this will cancel out the denominator, which turns to be a straight line. But the special thing about the straight line is it has a hollow point at x equals to 2, y equals to 7. But because this is a hybrid function, we have another part. So when x equals to 2, we also have a value 7 defined. Therefore, this point, 2, 7, will fill up the hole from the first equation. And f of x is continuous. So option A is the correct answer. Question 3. Question 3, I would like to quickly demonstrate your CAS calculator use. Here, I'm just using my TI Inspire. So for example, you can see all the options have, either -4, 1, or -1, 4. Basically, the reason why C is correct is because for this range of values, this function or this family of function will have no turning point. So if I look at my CAS calculator, here I'm just inserting another handheld page, let's say a graph. Let's use x minus h1 divided by x plus 1 times x minus 4. So you can create a slider for h1. And now you see, okay, when h equals to 1, this one looks like a point of inflection rather than a stationary point. So if I change this value to 0, it's still a point of inflection in the middle. If it's -1, yeah, it's just a reduced version of a hyperbola. And when h is -2, you can see there is a turning point here. So when h equals to -1, it doesn't have a turning point or stationary point. But when h is less than -1, you can see the turning point appears. On the other side, if you push that to 4, h equals to 4, you can see this is a truncus. But if it's greater than 4, okay, it gives you a local minimum, okay? So that is question 3. Question 4 is very algebraic. The correct answer is A. Couple of things to note. First, they gave you sine of x equals to A, and this x, the angle, is between 3 pi over 2 and 2 pi. This means quadrant 4. So you can use the Pythagorean identity to get cosine x is 1 minus sine squared, which is square root 1 minus a squared. The next thing is we care about cosine half x, so we need to half the angle range here, which makes half x between 3 pi over 4 to pi. You just divide 2, both sides here, okay? Divided by 2, both sides here. And therefore, my target angle of half x is in quadrant 2. Therefore, the cosine is less than 0. And the next stage of work is to use the double angle formula. Half x is doubled to be an x. Therefore, we say cosine x is 2 cosine squared half x minus 1. And it's also equal to root 1 minus a squared. And you can rearrange and isolate the cosine squared term. And you will get a 1 plus square root divided by 2. Then just notice what we observed. Cosine half x is less than 0, so you need to take the negative square root. So in my opinion, this question is more efficient by hand, but you have to know your trig identities and also the quotient positive, negative properties of any trig ratio. So be careful with the basics. Question 5 is a complex number question. It says the point z equals to 1 plus root 3i. Then we want to find a minus z bar minus z conjugate. What I'm doing here is I'll use the corresponding coordinates, or you can draw a diagram. For example, the first point corresponding to z is 1 root 3. And the z bar is negating your imaginary part, so it's 1 minus root 3. And the minus z bar is putting a negative to both. Therefore, you will get a minus 1 plus I root 3, which corresponds to minus 1 root 3. So it is a reflection, just a reflection about the y-axis. And therefore, we are saying we reflect the point representing z in the imaginary or vertical axis. Question 6, I would like to feature the CAS calculator use. First of all, we have a z equals to 3 plus ki, and k is a real number. We would like to get a more complicated expression and make it purely imaginary. If this expression is purely imaginary, the real part of this whole expression must be 0. So now, here is a screen dump from my CAS calculator. I just get real of that expression, but of course I need to tell my CAS calculator z equals to 3 plus ki. Therefore, what the CAS calculator did was to substitute this z into the quadratic expression and just extract the real part in terms of k. Then you can just equate the real part in terms of k to 0, and you find a minus 6 or 2, which is option D. Question 7 is a simple calculus or differential equation question. We call it separable differential equation. So the key thing is we have a combined term here, like a cosine x minus y minus cosine x plus y. Of course, we can make this term, this bracket simpler. So here, you can use t expand to make the cosine x minus y minus cosine x plus y term simpler, which becomes 2 sine x sine y. And also, if you use expand command, you will be able to rewrite ex minus y as e to the power x divided by ey. So this step saves us a lot of time. And then we can just rewrite dy dx as it is. And then we bring down or divide sine y both sides. And also I'll multiply e to the power y to the other side to keep all the y term and the dy on the left. And then I multiply dx on the right. Finally, I just need to integrate both sides, and this differential equation will be expressed in this integral fashion. Question 8 is an Euler's method question. So you have dy dx equals to x times y squared. 0 here is my initial x value, and the 1 here is my initial y value, which is y naught. The question didn't tell us a specific step size, but step size must be greater than 0. The question does tell us the third y, or the y value obtained by Euler's method after 3 iterations is this value here. Good thing is we have all the options available. So we can use trial and error with the Euler command on TI. Here is my screen down. Probably you could have trialed 0.01. Well, the setting out, I would like to draw your attention on this one, the setting out. So the way Euler's method works on TI is Euler, the command, you give the function on the right side, dy dx equals to this bit. Make sure you put the multiplication here, comma, independent variable x, comma, dependent variable y, comma. Then you use a curly bracket to write down the starting value of x and the end value, the target value of x. So after 3 iteration means, okay, from x0 to x1, that's one h. From x1 to x2, that's another h. From x2 to x3, that's the third h. Therefore, we encompass the 3h, 3 lots of h. Comma is outside the curly bracket, and then this 1 represents your initial y value. Eventually, you need to tell your class your h is your step size. And then you can just slot in a given that h equals to 0.02. And then if it doesn't give you the same value here, just try another option. So you'll be able to get the same option using h equals to 0.2. Question 9. Question 9 is actually a very lovely question because this reminds me of an old VCAA exam question. It was from 2017, the NHT paper. Question 11 from 2017, VCAA NHT exam 1. What I did here was I differentiate x and y with respect to t and slot in the arc length formula. And then you get a sine t squared plus 1 minus cosine t squared. Once you combine these two terms, you'll be able to get 2 minus 2 cosine t. And then you can use a half angle formula from your formula sheet. And the reason why we use that is because we want to get rid of the square root. So to get rid of the square root, you need a squared term, perfect square inside. And just notice the domain restriction, because when you deal with square root of a perfect square, it may come up with an absolute value. But the good thing is where we have half t between 0 and pi. This is in the second or the first quadrant. So the sign term will be always positive or 0. That's why we don't need to put absolute value here. Therefore, option A is correct. So I strongly recommend you go through this question using bi-handed algebra, because you may see other similar type of questions on exam 1. Okay, so just a bit background. This is actually a pair of parametric equations indicating a cycloid. So we are finding the length of the cycloid over one period from 0 to 2 pi. Question 10, we have option A. This is a surface area question. A similar question was observed in 2023, which was the first year of the new study design. And what you do is differentiate x and y with respect to t, and then slot in the formula. Make sure it's around the y-axis, because it's around the y-axis, your formula is 2 pi 0 to k x times the square root and dt. Then you just evaluate this integral. I think once you get to this step, once you formulated your integral for the surface area, you can use your CAS directly and get a 65 pi k squared. Question 11 is an interesting kinematics question with some calculus. You have the velocity time graph of the particle moving along an east-west line with velocity v meters per second at a time t seconds, starting from the fixed origin, and the diagram is shown below. The graph comprises two straight line segments. This is very important. And we've been told the initial velocity of the particle is 40 meters per second to the east. So you can see this is a positive v-intercept. And it's pointing to the east, which is a positive direction. And 150 seconds later, we would like to see how far the particle is to the east of O, so relative to the O. Here, I would decipher the question like finding the total displacement after 150 seconds. And we do need to notice the positive and the negative area. The size, for example, the size of this green triangle will indicate how far I traveled to the east. And also you can see the red triangle below the t-axis. This is indicating how far I subsequently traveled to the west or in the negative direction along a particular line here. What the CAS screenshot here shows me is 1. From 0 to 100, it's indicating the line with a negative slope. You can use these 2 points to find minus 3t over 5 plus 40. And it gives you the total signed area from 0 to 100. Basically, this bit will compensate some of the positive green area. And then this bit will also compensate another part of the positive sign area here, which means as a result, I'll be able to see, okay, what's the leftover for the sum of these two regions? And the final answer is 500, okay? The final answer is 500. That indicates my remaining displacement to the east. That's why it's 500 meters relative to the origin, the starting point. Question 12, the correct answer is B, actually. I'll fix that. But what I want to show you is, first of all, you have an xt relation, the position versus time. And the question tells you x equals to k plus 1. So you can equate this expression k plus 1 to the exponential term and get a particular time. Then you can just use your CAS to take the double derivative with respect to t and substitute t value you obtained above. And this is your acceleration. Second derivative of your position or displacement gives you the acceleration. This is my initial thought. But of course, maybe an algebraic and calculus approach is smarter and quicker, because when you notice you differentiate this exponential function twice, it's just this term multiply k minus 1 and then multiply k minus 1 again, which gives you k minus 1 squared e to the power k minus 1t. And this is exactly the same as x. Therefore, without finding t at all, I can just say, okay, because this k minus 1 squared is constant, when x equals to that, just put it here. Therefore, the acceleration for this x value will be k minus 1 squared times k plus 1, okay? So the correct answer is option B. Question 13 is a very usual vector dot product question. So we don't know this m, but we do have two vectors, and we know the angle between them. By the way, this is an acute angle, and we need to get m greater than 0 or r plus. What you need to do is you have to use a dot product between two vectors divided by the product of two magnitudes. I'm using norm. And this thing will indicate your cosine theta, which is just 13 divided by 21. So you'll be able to form an equation involving m. And then you use your CAS calculator to solve this equation, and this negative value is rejected. So m equals to 3. Question 14, this one, if I remember correctly, after I read through the assessment report, the stat was not very good. Only a small proportion of students selected the correct option. So let's decipher the question. We have a vector R and S. R magnitude is 9, S is 2i minus 2j plus k. So the vector resolute of R in the direction of S is this thing here. Just notice, if you look at the relation here, this vector resolute is minus 2s, okay? Minus 2s. So I started with the dot product. The reason why I started with the dot product here is because the vector resolute of R in the direction of S can be expressed as R dot S divided by S dot S. So this is a scalar factor times a vector S itself. That's why I calculated, let's say, R S dot S, which is 2 squared plus 2 squared plus 1 squared, which is 9. And then, because I know this is exactly minus 2s, and S dot S is 9. So I just substitute 9 here, and R dot S divided by 9 equals to minus 2, okay? This is observing, okay, what's the number relation between them? And I'm able to find R dot S, which is minus 18. Then we would like to find a scalar resolute of S in the direction of R. So according to the formula, we could have S dot R divided by R dot R dot R. This is the vector resolute, but the scalar resolute is S dot R divided by the magnitude of R. And from here, R dot S is interchangeable, so we can write it as S dot R, which is still minus 18. And this bit is minus 18 divided by the magnitude of R, and it gives me minus 2. That's why it's option B. I guess there are other smarter methods. I'm just playing it safer here, okay? Going back from scratch and the definition of vector resolute. And make sure you write the correct order of each vector. Question 15 is a lovely question. It has a lot of sentences to read through, but what you can do with your CAS calculator is to plot the parametric equations. This is a vector function, so I component is equal to x, j component is equal to y. And just notice, this is an angle t, this is an angle 2t. The common period between these two circular functions will be 2 pi. That's why I'm not going to choose pi. We can eliminate the c and d. There I just need to compare option A and B, okay? And the formula linking x and y will be cosine 2t equals to 1 minus 2 sine squared t. That's why option A is correct. But probably if you heard of my explanation, say, Mr. Nie, this is just too gut feeling. I can't do that. Well, we do have other options. Your CAS is able to plot parametric curves and animate the movement. So I'll show you my screen dump here. You need to change your entry type to parametric and make sure you type in the correct equations with domain 0 to 2 pi. Then you can just trace what actually happens here. For example, the starting point is t equals to 0. And now x, y is 0 and 1. Okay, so don't confuse between t, x, y. Next thing is once you increase your t up to 1.38, then 1.57 something, which is like a pi over 2. You can reach from 0, 1 to this corner, 1 minus 1. And then it comes back to 0, 1, goes to the left endpoint, and come back again. So option A is your correct option. Question 16 gives you the first vector and the second vector. So you can define them on your CAS calculator, and just be aware, R1 is cosine t first sine t next, square root sine 2t, whereas R2 is sine first cosine x, but the last term is the same. The domain restriction needs to be dealt with. The question says the velocity of particle 1. So we need to differentiate this expression either by hand or by CAS, preferably by CAS. Perpendicular means the dot product between the velocity particle 1 and position vector R2 equals to 0. That's why you can just define, V1 directly. Derivative of R1 is minus sine Ti plus cosine Tj. And then if you don't recognize the derivative straight away, you can just type it like ddt square root sine 2t. It gives you this thing. And then you define R2, which is sine t cosine t square root sine 2t. And then you just go for command here, zeros, because when you take the dot product between V1 and R2, it must equal to 0 for perpendicularity. Quote the domain restriction, you will just find one solution. This solution actually is a pi over 4, okay? There is only one t value, one such t value, and we give answer A. Question 17 is a classic vector lines equation problem. So we have the two parallel lines. And the way I find the distance between two parallel lines is, one, I will pick one point from each line. Two, I will use these 2 points to form a connecting vector between the two lines. In this case, I'm using I3jk to subtract minus 2, 1, 3, and I'm able to get a connecting vector 3, 2, minus 2. The next thing is, because the two lines have the same direction, I'm taking the unit vector of the direction, and then I'll do a cross product between the connecting vector and the unit vector. So this is, say, vector AP cross V hat. And then I just need to find the magnitude of this cross product, which gives me the square root 14 as my final answer. So this method is suitable when you are finding the shortest distance or perpendicular distance between two parallel lines. Of course, it has other suitable scenario. When time suits, I'll explain later. Question 18, the point of intersection of this line with the plane 3x minus 2y plus 4z equals to 5. I'll simply show you my strategy. This is a solve button. I solve 4 simultaneous equations. One equation is this one. Another equation is x equals to 1 minus 2t, y equals to 1 plus t, and z equals to minus 2. See the minus 2 here, plus 3t. So basically what the CAS calculator did was write out x, y, z in terms of t, and then substitute all of them into the plane equation so you can find t equals to 3. And then this t value goes into x, y, z component and find the coordinates. So the t here is just the time factor or dilation factor, or you call it parameter. But what we care about is the coordinate triple. Question 19 is a very simple but an important conceptual question. So if we consider a type 2 error, when we conduct a hypothesis test, let's say for a population mean, what defines a type 2 error? You can always refer to a table like this. I believe you can find a similar table on your specialist math textbook. This is when you don't reject H0, but your H0 is wrong or H0 is false. This is your type 2 error. So we say a null hypothesis is not rejected when the alternate hypothesis is true, because H0 is false may indicate your alternative hypothesis is true, okay? Well, this is the best answer. Probably some of you would struggle between option A and option D. A null hypothesis is not rejected when it is doubtful. This adjective doubtful means, okay, you have some suspicion. You are doubtful. But it doesn't necessarily mean the H0 is wrong or H0 is false. It might be true. Therefore, comparatively speaking, option A is a better option than option D. Finally, if you look at this question 20, it has a lot of reading in it. So the masses of avocados in a crop may be assumed to be normally distributed with a mean of 200 and a standard deviation of 7.5. After an avocado of mass M is peeled and the stone in the middle is removed, the mass of edible flesh, or you can eat the flesh, F grams, is given by F equals to 0.7 M. Just be mindful, this is a dilated random variable. So when you calculate the variance, you need to bring out a 0.7 and square it. And 4 avocados are randomly selected from the crop. Okay, I'll tell you directly what I do in one line. First of all, each avocado has available meat or flesh, 0.7 or 70%. So when you calculate the variance of one edible avocado, you need to use 7.5, the square, the original standard deviation, times 0.7 squared. Or you can just directly dilate the standard deviation, but you have to, let's say, write 0.7 times 7.5. That is the dilated standard deviation for the random variable f. The thing is, it's not just for one individual avocado, it's 4 individual avocados. That's why when we add them up, we say F1, F2, F3, F4. So you actually need to add 4 lots of individual variance together. And that's giving you 4 lots of 0.7 times 70.5 squared. How the norm CDF command works is it needs the standard deviation. So I take a square root of the combined variance. And then for the total or combined mean mass, I will multiply a 0.7 to 200, which gives me 140. So 140 will be the mean value of this f. And then we have 4 lots of them. That's why we have 140 times 4. Then I just want the combined variable f1, f2, f3, f4, all greater than 570. So it's 570 to infinity for the domain. And therefore, we get an option B, which is roughly 0.1705. So that is my quick review on the first 20 multi-choice questions. To get all the multi-choice questions done correctly, it takes a lot of practices. So I strongly recommend you walk through the past exam papers, especially in the past 10 years or 12 years. Not all of them are available to the current study design. For example, those questions prior to 2015, it did not have any proof stuff, or let's say other sorts of advanced calculus or differential equation stuff. But you definitely can get a lot of practice for all sorts of other questions like complex numbers, vectors, or let's say basic calculus applications or questions in context. And of course, mechanics stuff is not examinable anymore, but the kinematics is. So in the next video, I'm going to go through the section B, the 6 extended response question in great detail.